All right. So yeah, and it's just, unfortunately, it's like the particular question I'm thinking of is really tough to kind of grade otherwise. So I'll give you a little, just kind of a little hint here. One of the things that you're going to want to pay close attention to is this. Now, if I can actually remember what the question looks like. So when we create a module, let's just go ahead and download the. Oh, let's do attendance. We usually do attendance before we start recording. We'll just go ahead and do attendance, and then we'll talk about the exam. Have I shared a screen? It would help if I shared a screen. I think I've shared a screen. I am sharing a screen. Yeah. Okay, from Abigail Adams, still in the space of private virtue, a lot of private virtue quotes. Maybe we should lighten them up next semester. But to be good and to do good is the whole duty of man comprised in a few words. 1784, Abigail Adams. 1784 is between the American Revolution and the establishing of the Constitution. So just kind of, it's really an interesting period in American history. A lot of strange things kind of go on during that period. All right, that's attendance. Let's go ahead and get downloaded. The debugging and error handling is what we're on today. So this content is not included in the midterm. So kind of up to the stuff that we covered last time is what you'll want to be focusing on. And of course, there's the study guide in Learning Suite for that. But let's go ahead and download. Whoops, I'm on the wrong year. Let's go ahead and download. It's got to be here somewhere. Making, built-in, creating, debugging. Go ahead and download productlist.xlsm. And look, there's little errors. This is our debugging and error handling, so it shouldn't be surprised to see there's an error in this one starting out. But what does this line right up here at the top mean? Option explicit. What does that mean? Go ahead. That's exactly right. So by saying option explicit at the top, it says you must declare every variable that you're going to use. And if if your variable is just like 1 or 2 letters long, if you got something really simple, that's not such a big deal. But usually, if you got procedures that are maybe several hundreds of lines of code, and you've got lots of variables, and you're using really descriptive variable names, so they're long, which is a good idea because it gives you context when you're looking at the code. I understand what that variable is. Then it's really difficult sometimes to see a misspelled variable name. And so by saying option explicit, what you're saying is, hey, I've got to explicitly declare variables before I use them. And so, if I was going to try to test to see if you understood that, and by writing some code, what might I do? I might do something like this. Don't quote me on this. When you get to question number 37 on the exam, don't quote me, but if it's like, here's some code right here. It says option explicit at the top. And then partway through the code, the blocks of code I give you, none of them are very long. But like I start using a variable without declaring it. And there's an option on the test that says this code can't run. You should choose that choice. But it's always a contender. Yeah. And if you see option explicit and you see a variable being used without being declared, that code can't run. I don't think I've ever given that much information about that question on the exam before. We'll see how you do on that. Okay. Other questions? So yeah, I think other than that question, I don't remember the exam well enough to say for sure that's the only place you're going to see code that doesn't run, but if it's not, that's really close to the only time you'll see it. Okay. So today, dealing with how do we fix errors, and first there's 3 different categories of errors. So the first category of error is referred to as a syntax error. So syntax error is just an error that is so bad that the interpreter, like the software that actually looks at the VBA that you've written and makes the computer do something, the interpreter looks at what you've done and says, I have no idea what you're talking about. I can't even get started. I don't even know where to begin with this, with what you've written here. I can't figure it out at all. So syntax errors are typically pretty easy to find, because when you have a syntax error, the line will show up in red. In fact, we're going to make a little adjustment for you here in your code, like in your editor. How many of you like get really annoyed when you type a line kind of part like halfway through and you leave that line and a dialog box pops up and says, you've got an error? Well, I know I have an error. I'm only halfway through writing the line. And the worst thing is if you like hit enter by mistake, it's going to try to open help, and they should rename help to no help, because it's almost never any help. And so it's kind of frustrating. Well, what we're going to do is we're going to turn that off if you want to turn it off. So I'm just going to come in my Visual Basic Editor. I'm going to choose Tools, Options, and then Auto Syntax Check. I'm just going to uncheck it. So just take that off. When you have an error, the line will still go red, but it won't put that dialog box up, which I think is really annoying to have come up. And then if you don't have this one checked, it's a good one to check this one, require variable declaration. All that means is that when a new module gets created, it'll start with option explicit at the top. So this will go in automatically, and that is a really good idea. Okay, so the first category of error is a syntax error, and you might further split those syntax errors into two subcategories. So one is a syntax error that's like self-contained on a line. Like you look at a particular line, and that line just doesn't make any sense at all by itself. And those will show in red. The second kind of these syntax errors is where you have you've started a structure that requires something else to happen later, and you don't supply it. Those don't show in red because there's nothing to show in red. The problem is you're missing a whole line. Let me go ahead and just fix this one. Can you see the error? Do you see the syntax error that's here? Who sees it? Just say it out. See? Yeah, until is misspelled. So I'm just going to change that to until, and then that syntax, the red highlighting goes away. But let's just, so here's a do loop. It starts here and it ends with loop. Well, what happens if I take loop away? Is this syntactically valid? No good. And so, but because the problem is it's missing a line, there's nothing to turn red. And so you might be tempted to think, wow, anytime I've got a red line, I mean, anytime I have a syntax error, there's a red line. That's not the case. So a syntax error can be like the absence of something. Let's go ahead and run this and see what error it gives us when we try to run this. Not bad. It's a do without a loop. That's a really good error message. That's exactly what the problem is. I need to have that loop in there. But let's do this. Let's put another error in here. Let me just say if row equals 10, then debug.print. Let's put this down a line. Debug.print on line 10. That's a great message. All right. Syntax error here as well. What's the syntax error? Yeah, I'm missing the and if, but watch the error this one gives us. This error is really misleading. Why is it saying, so first of all, it's saying I've got a loop without a do. Is that the problem? No, that loop has a do. And so this can be really frustrating. You get this, Mary, what do you mean I've got a loop without a do? There's a loop, there's a do. It's pretty straightforward. I know I can see it. Why does it give this message? Oh, yeah, that's right. And so what it's doing is it's saying, all right, you want to start an if statement? Great, we'll start an if statement. We're printing this, that's great. And we get to this line right here, and it says, we're still in an if statement. Listen, you can't have, I mean, you can have a loop inside an if statement, or you can have an if statement inside of a loop, but you can't mix them halfway. And what it's saying is, I encountered this loop statement here, but there's no corresponding if. like that do that happened, or there's no corresponding do. That do that happened way above, that can't be the right one because it's not inside the if. And so kind of the thing to think about anytime you're dealing with a message from a syntax error is to say that that may not really be the problem that I'm facing. What it's saying is it got to the line that it's highlighting, and it's saying this may not be where the error is. In fact, this is not where the error is. Where is the error? Like the error is between these two. I'm just missing a line that belongs in here. And so it's not telling you that this is where your error is. It's saying when I got to this point, this is the point where I could not proceed anymore. The error may not be here, but this is where it becomes clear to the interpreter, there's a real problem and I can't move forward. And so the message can be confusing. The line that it highlights can be confusing. But the answer to this one is to put the end if in here, DIF. Now that should be syntactically valid. So you have these syntax errors, and it's just the interpreter is trying to figure out what you're trying to do, and it just can't. It's saying what you've written here is so bad. I just don't know what to do with it. And syntax errors, they just simply have to be, you just have to get rid of them. You just have to correct them. That's your only option. Now, there's another category of error. And this category of error is called a runtime error. Runtime errors are syntactically valid. The syntax is okay. Here, why don't we do this? Dim row as long, do until products.cell. Let's just make a little example of a syntax error. I have a runtime error. Sub runtime error. You then sub on there, I did. And let's just say debug.print out of all the sheets, out of all the worksheets. By the way, there is another collection called sheets, and I think it sometimes gets recorded this way instead of worksheets. The collection of sheets is different from the collection of worksheets. What does the collection of sheets have that worksheets don't have? What other kind of sheet can you have in a worksheet, in a workbook that is not a worksheet? I was confused about this because I'm not really a power user of Excel. I mean, I program a lot in it. But there's actually another kind of sheet you can have that's not a worksheet. You know what it is? What I really wished it was like a text editor. So many times I'd love to have like just a sheet of text as a worksheet. You can't do that. It's so I heard someone say it, like a chart or a graph. Yeah, those can be on their own sheet. And so if you were talking about the collection of sheets, that's all your sheets, worksheets, and chart sheets. I'm just going to stick with worksheets here. Debug.print worksheets, and I'm going to say here sheet 1. And we'll say dot used. What is it? Is it like used region? Now I forgot what it's called. It's called used range. We're just going to print the address of the used range on sheet 1. Now, syntactically, that's fine. The interpreter looks at this and says, no problem. I can run this. But what's going to be the problem when it tries to actually execute this line? There's no sheet 1. And so the interpreter looks at this and says, this is great. You're referring to the print method of the debug object. So it's like, I'm going to be putting some stuff up here in the immediate window. And it goes, we're trying to look for the collection of worksheets. I know what that is. There's going to be some string that defines the worksheet that we're going to be using. That's great. This all looks used range. I know what all that is. But when we go to run it, it says subscript out of range. Not the most helpful of error messages. But it's saying, hey, there's no, by the way, the reason they call it a subscript, I mean, what really is a subscript? Subscript is like you've got a word and you've got like a little number off to the side of it and it's dropped down a little bit. That's what a subscript is. And so when we're referring to what we'd really like to do, when we're referring to like a sheet, we'd like to be able to say, out of all my worksheets, I'm talking about worksheet number 1. but I don't want that to be like a number out there. I want that to be a subscript, but you can't just do subscripts like in programming lingo. Boy, today you probably could. We could probably actually make that go as a subscript, and we could figure out a way to make that work. But back when they're like inventing programming, you got one line, there's no subscript, there's no superscript, it's just text characters. And so what they did was they said, oh, why don't we put it in parentheses, and that's how we'll express a subscript. And so if I wanted to, I could print like the name of whatever worksheet number 1 is. And what we're saying is, oh, that's our clever little notation because we can't make a subscript. That's how we're going to make something that we want to put as a subscript be a subscript. And so when we say, well, you can identify it instead of by number, you can identify it by its name, it's not really a subscript anymore, but it's the same problem. You're trying to identify an element in the set that doesn't exist. And so that's why that message, that's where the message comes from. It's a bad message today, but that's the reason that it says the way what it says. So the syntax is okay. The interpreter looks at it and says, that's great. Now, would it be possible for us to, like, at the time that we go to run this, could Excel like look over all the sheets and see if that sheet exists and give us an error? Like when we try to run it, that says a runtime error, a compile time error that says, hey, there's no sheet 1. Is that within the capability of our environment? Yeah, totally is. But why would that be a bad idea? For it to look at that and say, hey, that's not going to work because there's no sheet 1. It would be a really bad idea to do that. What is it? Yeah. Exactly right. Not necessarily in code, but like the user could create a sheet 1. Like we can't even look across all the code and say, is it possible this is going to get created? The user could just create it, and we know the user is going to create it before they run this code. The interpreter can't know that. And so it just says if the syntax is right, we're going to try to run it. And then when it tries to run it, it's like, oh, can't do it. So these are runtime errors, and we have 2 options for runtime errors. For runtime errors, we can either eliminate them or we can trap them. So we're going to see kind of both approaches to solving this problem, either eliminate the error or to trap the error. And then the third kind of error is the most difficult ones to track down, and that's referred to as a logic error. A logic error happens inside your brain. So a logic error is what you wrote, like the code you wrote is syntactically valid. When the interpreter tries to run it, it runs just fine. The computer is doing exactly what you told it to do. The problem is you're telling it to do something different than you think you're telling it to do. And those, we just have to get rid of those as well. There's no way to trap them because the interpreter never knows there's a problem. It's just doing what you told it to do. And for those, that's why we have the whole suite of debugging tools, because they are really difficult to track down. And so we're going to learn about what some of those tools are for tracking down those runtime errors. So syntax errors, you got to get rid of them. You can't even run until you do. Runtime errors, either eliminate the error or you're going to trap the error. So let's do this. What we're doing here, we are looking down let's see, we're printing column 1 and we're printing column 6. I'm just going to run this again and see what it does. I don't even know what this code does. Subscript editor. I don't think I was trying to run that one. Let's run this one. There we go. All right, so we've got 860. Okay, so it looks like we've got, these are just products. This is like the product ID. This is the product name. If we go back and look at our, this is just like some products. So we've got 1, 2, 3, 4, 5, 6. Yeah, so here's the product name. I don't know what else we have, but let's suppose that what I'd like to do is I would like to create a set of, I would like to just create the set of departments here. So I've got like 800 rows here, and it looks like a bunch of these are in the hunting department, outdoor, apparel. I don't know. I'd like to just make a list of what's here. Now, one way to do that would be to like copy the column over to the other sheet and then do like, what's it called? Remove duplicates on it. That would make the unique list. But for this example, I'm just going to, as I'm running through this code, I'm going to say, listen, I've got to run through that code for whatever reason. Let's just make the list of our, what is this called? departments. So make the list of departments that we have here. And so let's do that. I'm gonna make a new sub procedure here called add item to list. And so we're going to give it a list name as a string. And we'll also give it an item as a string. The idea is what I want to do is I want to say, oh, I'm looking at something right now here called outdoor or hunting. And I'm going to say add hunting to the list. Now, what I want my add to list to do is I want to say, oh, we're only going to add it if it's not there. So you told me to add it. That's fine. I'm not going to add it unless it really needs to be added. And then we'll move on. It's just going to make sure that we've got that list. And we're going to build these lists on a worksheet named lists. So let me dim S as a worksheet. And let's set S equal to worksheets named lists. And then we'll do some other work with it. But this is going to give us an error when we try to do it. So let's come in here. And after I do this debug.print of the product, I'm going to call add item to list. I'm going to give it a list name, which is department. And the value that I'm going to give it is whatever the department is. Is that in column 2? I don't remember. In column 3. So I'm going to get here. I'm going to say, great, add item to the list. We're going to tell it the list is called department, and the value we're trying to put in is whatever value is in column 3 of the active row. We're going to run this, and this should give us a runtime error. Let's just run that and find out if that really is what happens. Subscript out of range. Great. So our options here are to get rid of it or to just trap it. We're going to do them both. Which one do you want to do first? I don't care. You don't care either. So let's, why don't we go ahead and let's get rid of it first. So how could I, instead of just running this and having it fail, what could I do to say, wow, you know what? I see that I need to create the sheet. And so create the sheet, and then we'll be able to refer to it. So how could I know that I have to create the sheet? What algorithm could I use to say, oh, I see I need to create the sheet? There's no function built into the collection of worksheets that lets me ask if something exists. Like I can't just say, does this sheet exist, and have it return true or false. But I might be able to create a function that would do that. If that's what I'm trying to do, what's the algorithm? What would I do? Just give me the steps in English to see if a sheet exists or not. I'll get started with the function that will do that. So we're going to create a function in here. Function. Sheet exists. We'll pass it a sheet name. Oops. As a string. Let's just do that. We're going to assume that it's in the current workbook. So rather than trying to figure out what workbook to look at, we'll just assume it's in the current workbook. So how can I find out? How can I tell if a sheet already exists? If a sheet by that name already exists? I believe that you guys could do this. We've covered enough in this class. We're not inventing anything new here. It's like applying stuff we've done. Yeah, go ahead. We need an if statement. But because that if statement needs to look at every single sheet, what else do we need? We need a loop. Yeah, so we'll make a loop that looks at every single sheet and just going to check to see if the name of that sheet is there. So let's do this. Let's say, and let's go ahead and do a let's do a for each. This would be great for the for each loop. So let me dim S as a worksheet. For each S in worksheets, next. So this loop now is going to iterate across, we're going to go through this loop once for every worksheet that there is. And importantly, the variable S is going to get connected on to each worksheet as it goes. So if I was just to print here, debug.print S, I would get, or s.name, I would get the names of all my worksheets printed out. Well, I don't really want to print it out. What I want to say is if s.name is equal to sheet name that got passed in, then we're going to return true. Otherwise, we'll return false. Now, if we set this up as a Boolean, then the only thing this can return is true or false, and it will return false unless I tell it to return true. So if we've found a match between the name, let's go ahead and say that the name of the function equals true, and then we're done. So if we get all the way through this loop and we never found a match between the sheet name that was passed in and the sheet name that was passed in and the name of the sheet that I'm currently looking at, we never find a match, we'll never set sheet equal to true, so it can only return false. So this is nice. Well, let's do one more thing here. Let's do a case insensitive comparison. So if we've got a sheet with names, the only difference is uppercase versus lowercase, we're going to want that to be the sheet does exist. So there's a couple ways to do it. Here's a simple way. I'm just going to uppercase the name that I'm looking at, and I'll uppercase whatever was passed in. So now, whatever case they're in, we're going to force them to uppercase before we make the comparison. Okay, so now what we can do here is we can say, if sheet exists and the name that we're looking for is lists, then set S equal to that. Else, what do we do in the else? We'll set S equal to a new sheet. Then we'll give S that name that we want to have. So either way we get through this, we're either going to say, oh, there already is an existing sheet, we're going to go ahead and bind onto it. But if that's not the case, if the sheet doesn't already exist, we're going to create a sheet and we're going to call it that name. But either way that we come through this, S is going to be bound onto a sheet named lists. And then I think from here, let's just stop when we get here. So I'm going to come back then and run my main loop. Oh, it should be s.name equals lists. And that should have created it. Looks like it was actually on that line when it failed because I spelled it wrong. So now we've got a sheet called lists. Next time we run this, we're not going to go through this block of code because it will exist and we'll end up going through this block of code. Show me where you are and what we've done so far, 0 to 5. Like, 4 is probably, I followed it well, everything you said, but I might not have been able to do it on my own. 5 is, yeah, I probably could have done this. So mostly 4, so folks are voting, okay. All right, so that's one approach that I have for a runtime error, is develop my code such that it just prevents the error from happening. It notices the condition that's going to cause the error, and then it routes the code differently based on that condition happening. This is probably the preferred way, generally speaking, the preferred way to deal with a runtime error, is to say, make my code anticipate that the error is going to happen, and then handle that error, or handle the code in a different way such the error never happens. Now, it could be that imagine if there were 1 million worksheets in this workbook. I don't think you can have more than 255. And the truth is, to look at all 255 wouldn't take long. But imagine that we've got some process that actually takes a long time for us to figure out if the error is going to happen. We might say, you know what? It's just going to be a lot more efficient to say, let the error happen, but let me see that it happens and then decide what to do based on the error happening. In some cases, it's dramatically faster. In other cases, there's no way to really check to see if it's going to cause an error without trying to do the thing that it's going to cause the error. And so in those cases, we're going to say, look, just try to do it. And if the code fails, then we'll go and make some other provision. So instead of saying, let's not run the code that's potentially hazardous, just go ahead and run the code that's potentially hazardous. But then if an error happens, we can deal with it. And so that's going to be our next approach. So this approach is prevent the error from happening. Prevent. And that's the approach that you want to take every time, unless you can't do it, or unless it's really expensive to do it. It would take a lot of processing power to be sure the error is not going to happen. So I'm going to comment this out for now. So our other approach is just try it. And if it fails, deal with it. All right. So we're about to look at some syntax like VBA code that is like bizarre. It's like really strange. And it goes back to like the really early days of BASIC. Strange as it may seem, in the very early days of BASIC, every line that you wrote, you had to put a number on. This is line number 1. You would say 1 space, and then you would put your statement. Next line, 2 space, and you would put your statement. This is like back to the 1970s. And it was hideous. There were other programs you could use just to renumber your lines of BASIC. I need to renumber my lines. So you'd run another program and it would go renumber all your lines. And you would actually use those line numbers to kind of tell it to jump from one place in your code to another. It's way better now, the way we do it. But we're going to see kind of an old vestige of that right here. So here's what we're going to say. We're going to say on error. This is our way of saying, all right, interpreter, after this line executes, if you run into a runtime error, I'll tell you what to do. The whole reason it stops when it gets to a runtime error is because that interpreter is just happy as can be. I mean, look, he's so excited to actually finally be doing something. It just runs right along doing happily whatever you tell it to do. It gets to a line that it can't do, and it's like, I'm stuck. And what we're going to say here is say, listen, if you ever get stuck, don't despair. I'll give you something else to do. And that's what we're saying here. We're saying, listen, if you run into an error, I'll tell you how to deal with it. Don't just throw up your hands in disgust and say, I'll quit. Just say, here's a way to solve it. And this first way that we're going to do that is we're going to say on error, resume next. On error, resume next tells the interpreter after this line executes, this on error, resume next statement, after this line executes, if you get to a runtime error, skip it and move on. This is a really dangerous line of code. This automatically turn. If I just put this at the top of my procedure, it will guarantee to get rid of every runtime error. But it converts it from a runtime error into what kind of error? It turns to a logic error. Yeah, it says, hey, there's something you can't do. Great, it must not have been important anyway. Just keep moving. It's a really dangerous thing. So we're going to be very careful when we use on error resume next to scope it right down to just the lines that we think might cause a problem. And the line that we think might cause a problem is when we try to bind S onto that S variable onto that sheet by that name. This is the line. This is the suspect line. And then I'm going to put right here on error, go to 0. That's the bizarre line in all of this. In the old days of BASIC, the very first legal line number was line number 1. There's no such thing as line 0. And so when I tell the interpreter on error, go to 0, it's telling it to do something else that it can't do. If there's an error, do something else that you can't do. And that's going to cause it to stop. So what we're saying here is we're saying this line says, hey, if there's an error, just keep on moving. We're going to put some other code around this. This one says, hey, if there's an error, stop again, just the way you used to. Like when you get an error, a runtime error, before I say on error resume next, if you get to a runtime error, it stops. You know, it takes me into break mode. It shows an error message, shows a line of code that it couldn't process on. And so this line here is just telling it to go back to its normal error handling behavior. Return to your normal error handling behavior. It's a really weird way to say it, but that's what that means. All right. Now, I'm going to do one other thing right before I get there. So at this point, I want to know if an error has happened. So let me just put a stop right here. So we're going to run right to this point, and then I want to see I want to kind of see how I can tell if an error has happened. So in so doing, I'm going to go delete my list sheet because I do want that to have an error. So I'm deleting that sheet called lists. Thank you. Just delete it. And when I run this, I will expect it to hit that breakpoint. So I'm running the one above it called process products. Okay, and it's got to right here. So it's printed off. I'm on row number 3, apparently. Really? I wonder why I didn't start with row number 2. Make sure that it didn't create the sheet. Didn't, okay. I'm not sure, I have to look at the code more closely to see why I'm getting 3 instead of a 2 there the first time through. But my important point is here that I've stopped. I tried to bind this line, this variable onto a worksheet, and it's and then it just stopped. That's so I can introduce the error object. So there's an object called error, error. And it has a property called description. Subscript out of range. The same thing that it puts into the dialog box when I just bump into this error as a runtime error before I've trapped it. I now have access. I can look at the error object and see that. Not only does it have a description, it also has a number. This is error number 9. In fact, if it's error any number besides 0, error number 0 means there's no error. But if it's any number besides 0, it's some kind of an error. So I'm going to say if error.number equals 9, and this is the error trap. We're setting up the trap here, and then this is going to be our error handler. We're saying there could be all kinds of, I don't know what other kinds of things could cause an error at this point. But if it's error number 9, I know exactly what it is. I'm trying to bind onto a sheet that doesn't exist. And so what am I going to do here? I'm going to make the sheet exist. I'm going to do these same 2 lines of code that I had when I was preventing the error from happening. So if error number 9, this means the sheet doesn't exist. Otherwise, well, again, as we exit through here, in fact, it may be a good idea for us to put the on error go to put it up here as well. So what we're saying is that I'm really narrowing this resume next behavior, which is so potentially hazardous. I'm saying I'm just going to try to execute this line, and then I'm going to check to see if it's error number 9. If so, I've accomplished what I was trying to accomplish. I tried to do something and it failed. And so now I don't need that error trap around anymore. So I'm going to turn that error trap off. Hey, if I have a runtime error in my code now after this, I want to see the error because it's something I haven't anticipated. And what do? We then add a worksheet, we bind the variable onto it. And so if this runs without error, we're never going to come into this if statement. If it runs with an error, then we will come in and do this. So we will have tried this, it will have failed, then we'll do this. But either way that we get past this, S will be bound on. And so that should do the trick now. I'm going to go ahead and stop that. I'm going to get rid of my stop. I'll run that again, and it should give me the sheet. And yeah, I'm going to get rid of this stop as well. That's probably enough because it will have created it by now. There, it's created that sheet. So that is the idea of an error trap. So we say, hey, we're trying to anticipate, we're running a line of code that we know is risky. And so we're going to let it happen. If it throws an error, we're going to check to make sure it is the kind of error that we were expecting, and then behave accordingly. Well, what if it's a different error? What do we do if it's a different error? What if it's error number 6 instead of error number 9? What's that? Well, in this point, if we end up in there, well, let's go ahead and do this. Let's say that I'm looking for error number 6. I'm going to reverse the problem. I'm looking for error number 6. And so now this is not going to trap it. This would be identical to some this is now some different error is happening than I'm anticipating. You go ahead and clear off that list sheet. And I'm going to leave the stop in there. So we only run through once. And I'm going to run this code again. So now the difference is I've just changed the error number I'm looking for. So I'm not going to go through this line because it's going to be error number 9. So what I'm exploring right now is what happens if it's a different error than I'm anticipating? What's going to happen? So I'll run that one. We'll hit stop right here. So still no error. That's great. But what hasn't happened this time? Like the sheet didn't get created. So the point here is that if an error happens that I'm not anticipating, I have accidentally handled some different error. I don't want that to happen. So I'm going to say this. I'm going to say, listen, if it's any error besides the one I'm anticipating, and maybe I'm anticipating 2 or 3, I could build this structure out to be a little more sophisticated. But if it's any error besides the one that I'm anticipating, just go back and make the error happen as normal. And so I'm going to put that in an else statement here. And of course, I could have like multiple else ifs in here. And what I'm going to do here is I'm going to tell it, listen, what I want you to do is just bring that error up. Just that error that we've trapped, present it like normal. And I do that with a method of the error object called raise. The raise method then takes a number that I want to actually display. And I can like even make my own custom errors this way if I want to. But here, I'm just going to say, oh no, just whichever one I was not expecting, that's the one I want to see. What's the number of that error? That's error.number. The next one is a source. And that's also a property of the error object. And then the description as well. I think that's right. SURCE. Truth is, I don't often use source and I forget what it is. Let's run this and see what it does. So now we're going to try to bind onto a sheet that doesn't exist. We're going to check to see if it's error number 6. It's not. So we'll jump here and we'll re-raise that error. So you stop this, run my code again. And it seems like I should have hit that. So let me put a breakpoint here. By the way, this is another thing that we're learning today, breakpoints. So far, we've done breakpoints in class just by writing the word stop in. Another way to get that behavior to stop is to click right there in the little margin here. You get a little round, somewhat round mark. How many of you have done that by mistake? Clicked on there by mistake. You got the circle. What is that? You go, oh no, what have I done? You clicked on it again, it went away, and you went, whew. So that's now a breakpoint. So when I run this code here, that's going to break me right here. It's going to say, oh, I'm going to take you into break mode. And the line that's yellow is the current statement. That is the statement that we're getting ready to execute. We have not executed that line yet. So now the idea is we're going to start to go one step at a time. How do we go one step at a time? We come to the debug menu, and there's this thing here called step into, step over, and step out. They all execute the current statement, but they do it in slightly different ways. Step into, and the only time these first two are different is if you're making a call to a sub-procedure. Step into, if you're on a line that's calling to a sub-procedure, what do you think step into will do? A little louder? Yeah, it'll go right into that sub-procedure. You hit step into, and it'll take you to the first line inside that sub-procedure. And then you step into again, step again, step again. You'll go through all those. Step over, it's tempting to think it means skip this line. After all, if I'm walking down the street and I see something on the street that I don't want to step into, what would I do? I would step over it. Like without doing it. But that's not what it means here. In this case, what it means is go ahead and just run that whole sub-procedure. I don't want to go one line at a time through the sub-procedure. Run the sub-procedure, but just run it as if it's just one native statement. So step over doesn't skip anything. It just skips the stepping part of it. So step over and step into will do the same thing unless I'm on a call to a sub-procedure. Step out says, hey, if I'm in a sub-procedure, step out will say, finish this sub-procedure without stepping it and take me back to where it was called from. So I almost always, like my default stepping is step over. And then if I want to step into something, I'll do that differently. So I just use Shift F8 to step because going to the menu is kind of a hassle. So I'll do Shift F8. Now I'm curious to see what my error number is at this point. It's error number 9. It's not error 6. This should raise the error. Oh, it's because this suppression here is happening only in this part of my code. I've raised the error, but that error has been trapped. So that's what I got to do. I need to bring that on error go to and put it here as well. But this is like one of our biggest tools for working with logic errors is putting a breakpoint and then going one line at a time to see why is it doing, where is it going? Because logic errors, it's almost always going somewhere that you don't think it's going. So I'm going to run this again now that I've added the on error go to here. There we go. Oh, invalid procedure call or argument. Raise. I was kind of expecting number 9. I'm going to step through that again. Stepping, Shift F8. You didn't get to 6. You see what my error number is here. Step right here. I think that's going to reset my error number. So right now the error number is 0 because when I say on error go to, on error go to 0, that should turn it off. that should raise the error. Let me step on that one. So I think the invalid procedure here is happening because my error number is not defined. I need to be a little bit more thoughtful about this. Let me just try something really quick to correct this. It's behaving differently than I expected it to. So hold on just a moment. Let me stop my code. And this is going to take longer than I thought. So we may revisit this to be a little more sophisticated, but let's just kind of pause on this for now. And kind of the important things that we've seen here is that on error resume next says, hey, if there's an error, keep going. On error go to 0 tells us to go back to normal error handling after that. And I do want to spend, we may have some time at the end, I can come back and revisit this example, but I do want to look at the other debugging tools. So probably the bread and butter of debugging is getting to a breakpoint and then working with your immediate window. So I'm going to go ahead and put a breakpoint right here. We'll run our code to that point. So at this point, I haven't reset my error object. The whole idea here now is that when I'm in break mode, when I've got that yellow line, my code has run up to that point, and everything that I've put into memory is still in memory. All of my objects are just suspended and paused so that I can say, hey, I wonder what the state of things is right now. And so that's why I can come up here and say, hey, I want to see what the description of the error is. And it will tell me that because I'm in break mode. If I was to stop this and then run that again, it would say, like, yeah, there's nothing. I don't know what you're talking about. Can I ask what the error number is? Yeah, so it's error number 0 right now. That object is still around, but I'm not suspended in my code at all. What if I had a variable like s? Can I see what s is at this point? Well, I can't because, or s.name, because that variable isn't actually in memory right now. It's only in memory while that subprocedure is running. And so being able to get to a breakpoint and then probe to see what's my code right now is really handy. Here's another one that's really, really helpful. Let me go ahead and, in fact, I'm going to put a breakpoint up here. Kind of one way, put the breakpoint here. And we'll run this code. All right, now let me introduce you to something we have not done yet in class. I'm going to come to my view menu, and I'm going to view another window called the locals window. What the locals window is, let's see if I can get it to dock over here. I like it to dock side by side. There we go. What the locals window is it says, all right, we've got here inside our, this is like all of our local variables. So right now it's saying you've got a variable called row and its value is 2. Let me just drag my current position, my current statement indicator down to where we add 1 onto it. And I'm going to execute this line, just one of them, by pressing F8, and watch what happens to that tiny little 2 right there when I press F8. It updates automatically because this now is showing what is the current value for all of my locally declared variables. And if I have variables that are declared at the top of the module, have we talked about module scope variables yet? I don't think so. These are variables right now just declared inside of a particular subprocedure. If I declare them outside of a subprocedure, they'll show up here. And so as I'm going through, I can go step at a time and I can see exactly what all my variables are. I don't have to pause and then go to my immediate window and say, print off that variable, print off that variable, print off that variable. So the locals window can be really, really helpful in debugging your code because you can, as you go step by step, you can see how everything is changing. Question on the locals window? All right, let's take a look at a thing called the watch window. So let me view my watch window. My watch window is like the locals window, except it's a little more sophisticated. So the idea behind the watch window is to say, I've got specific things that I want to keep an eye on. And they can be more sophisticated than just single variables. I can put any expression I want to here into my watch window. Here's how we do it. I'm just going to, well, let me come here to row, and I'll right-click row, and I've got add watch. Like this add watch is just a menu choice. And I'll say OK for now. And that now puts row here in my watches. So maybe I've got dozens of variables declared here, and I don't want to see all of them at once. I can just say, let me just tell you which ones I want to see. So that's one. But that doesn't need to just be a bare variable. It could also be a more sophisticated expression. Let me go ahead and right-click this again and say add watch. And so instead of the expression just being row, I can say row is less than 4. That's an expression that can be evaluated. Now that whole expression is going to be true or false. And as we run, so if I come here and run row equals row plus 1 again, you're going to watch now two things change. This will go to 4 and this will go to false because then row will not be less than 4. So that expression row less than 4 is false. So I'll run F8 to run that, and it's updated both of those two values. So the watch expressions are really helpful for doing things more complex than single variables. And to kind of narrow down. So I'm just looking at the ones that I want to see. There's one other thing that we can do with a watch expression. And that's this. I'll go back to my row variable, and I will add a watch expression here. Now, the default type here is watch expression. But I'm going to change this to say row is greater than 5. I'm going to make this into a break when value is true. Now, what I've just done is I've made what's referred to as a conditional breakpoint. What I've said is, hey, I'm not quite sure why row is ever becoming larger than 5. But whenever that happens, stop, so that I can see what's going on when that happens. And so a conditional breakpoint says, instead of saying, I want to stop at this point in the code, you're saying, I want to stop when a certain condition is met. I don't know where it happens. But when a certain condition becomes true, that's when I want to stop. So I'm going to go ahead and add that as a conditional breakpoint here. And I'm going to stop my code. And I know I've got, let's see. Let me change this back to if it's number 9, we'll deal with it. That should stop that from having a problem. And I'll run my code now. And I'll get rid of that breakpoint and run my code. Not quite sure. I got to figure out why this is happening. What's ERR right now? So it's like I've got on error go to 0. Like I've got some other error. Let me just take a minute on this. Check your email. I'm going to put a watch expression on this. Error number is 0. Oh, it's probably because it's created. What I need to do here, here's the problem. What I'm saying here is I'm saying, hey, if error is number 9, handle that error number 9. Otherwise, do this. But there's one other condition where I don't want to be raising that error. And that's when there's no error. And so, go ahead and stop this. What I'm going to put on this trap very first I'm just going to say if error number equals 0, then do nothing. That's going to prevent it from hitting this else down here. Or maybe it would be better to do this. Else if error.number is different from 0. I like that better. So if error number 9, handle it the way we expect to it. If error is something other than 0, raise that error. Otherwise, just move on. So if it's either 9 or 0, we're going to prevent that from happening. All right, I'll run that. Good. Okay, so now that takes care of the problem that we had down here. I just need to make sure that I was handling the 0 condition when there's no error. But why did it stop here on do events? We run it again. So it highlighted this conditional breakpoint. It highlighted this watch right here. And so what it's saying is row number is now 6. So this condition is true. And that took me into break mode. It would be fantastic if it stopped on this line somehow. But it stops on the next line right after that happened. And so it stopped right here. It hasn't run the do events. And it got triggered because that line before it that ran made that conditional breakpoint true. And so that's what takes us into break mode. Show me how you're feeling about conditional breakpoints. This idea of having a breakpoint that happens when a condition is met rather than on a particular line. Okay, anything you want to hear more about watch expressions or the locals window? Well, why don't we take the next 8 minutes or so and just kind of flesh this example out then. That's, let's see, any other tools I want to talk about for debugging? Oh yeah, so one other thing that I do want to show is that, and this is really unusual. I have never seen any other debugging environment besides VBA that lets you do this, that you can drag this around to say, you know what, from this point, I want to go right back to here, or I want to go forward and skip that code and go to here. So that's a really powerful thing while you're debugging to say, you know what, just skip that line and see what happens if we move on. The other thing you can do is, instead of dragging that there, you can come to the debug menu and you can say set next statement. And that will set that as the next statement. And similarly, if you're somewhere else in your code and you're not even quite sure where the next statement is, you could have 4 or 5 different modules open. Where's the next statement? You can say, hey, show me the next statement. And that'll take you to where the next statement marker is. And so that's the really handy part here. But let's see if we can then just actually make this do what we want it to do. So down here where we are adding an item to a sheet, add item to sheet. So at this point, we've got our S bound onto that. What I want to do is I want to look for the name of the list on that first row. My idea here is that I'm going to have a list that goes across here. The name of the list will be here, and the values in that list will be under it. If I have more than one list that I'm building in this little application, I'll add another list. The name of the list will go there, and its values will go under it. And so let me declare another variable up here. I'm going to call it found cell as a range. And what I want to do is I just want to look. So dim found cell as range. I want to look across that first row. So my worksheet is called S. I want rows number 1, and I want to find. What am I looking for? I'm looking for list name. And then I'm going to skip the next 3 arguments, and I'm going to say I want that to look as XL whole. If we recorded ourselves doing a find again, we'd be able to work through this. XL whole. But this says I want to find, I'm going to look at my worksheet, my first row, and I want to find whatever got passed in as the list name, and I would want to search for the whole contents of the cell, a match completely on that. Now what I'm going to do is I'm going to set found cell equal to this. It will either find it or it won't find it. If it finds that value, it's going to bind, let me say found cell, it's going to bind found cell onto that cell. But if it doesn't find it there, it's just not going to, it's going to say, yeah, we didn't find anything, it's going to move on. In that case, found cell will be unchanged from its initial value. Every variable type has a default value. Every string starts as a zero-length string. Every number starts as a 0. Every Boolean value starts as false. Every object variable starts as nothing. Remember, object variable just points at another location. And there's an object built into VBA called nothing. It is the only object I know of that has neither properties nor methods. It is just a placeholder. It's a location in memory that's defined as an object. And when I create a new object variable, it refers to that nothing object. And so what I'm going to say is, if found cell, and the way I check for equality between objects is with the is statement, the is comparison. If found cell is nothing, then what does that mean? It means we didn't find it. So here, this means that our list name is not on the list sheet. So in that case, we just want to add it. So here's what we're going to do, s.cells. And I'm just going to go all the way to the left-hand column on that first row and then come back until I bump into something. So row number 1, column number, s.columns.count. From there, I'm going to do end, XL to left. That'll be like going to the way far end and doing control left to come back till I bump into something. And then here, I'm going to say I want to offset. That'll be the one that actually has text. I want to go one past the one that has text. Same row, but offset by 1 column. I'll set my found cell equal to that. And then I'm going to put a value into found cell equals list name. So if I find it, found cell will be bound onto the cell that has that label in that first row. If not, we're going to come to the end of our contiguous data, and we're going to add that cell into that row, and found cell will be bound onto it. So either way, when I get to the end of this, I will have found the column that has the list name there. So maybe I'll declare one more variable up here. Then column as an integer. Then I will say column is equal to found cell.column. And so at this point, I will know the column that I have to write my data to. We don't have time to do the next part of this example, but it would say using that column number, I want to do another find. I want to find if the value that I'm trying to write to this sheet is already in this column. If it is, I'm done, move on. If it's not, I need to add it to the end of the list. So it would be something really similar to what we did by putting the list of the list name on the first row, but it would just be adding the value to the end of the column that we've identified. Let me just go ahead and make sure that works. You put a stop right here and run my code. And I passed in list name without a hyphen or an underscore. And that should have put that item on the list. Let's take a look. Yeah, so department now is here and we're building that out. Okay, so that's examples of dealing with error trapping, also called error handling, and our debugging tools. Any questions? See you Wednesday. Hope you'll take the test before Friday so you can take it for free. Class dismissed.